let's take a look of this sample problem number 1. So actually, this sample problem number 1 is an example that we solved before during module 1. No, kaya lang, during module 1, we analyzed this connection against tension failure, yung GSY, tsaka NSF, tsaka black shear. This time, we will resolve this problem, but this time, what we're going to consider are different failure, different limit state. We're asked to determine the design strength, that means VRN, based on the following failures. This time, shear on bolts, tsaka bearing on plates. So, hindi na natin isosolve yung GSY, NSF, tsaka black shear fracture. Ibang failure naman. Again, remember that for bearing, dalawang possibility, pwedeng shear tear out, pwedeng hole deformation. Okay, first, let's start with the shear on bolt. So, madali lang pagka shear on bolt. So, what I'm going to do is to analyze it per bolt. Okay, so sa isang bolt, okay, so that would be FNB. FNB is 165. This is given. No, that is the shear strength of the bolt, 165 megapascal. Multiplied by the area of the bolt. And the area of the bolt is simply pi over 4. Diameter niya is 20 square. So, 51 kilonewton ang Rn niya per isang bolt. So, para kung makuha yung shear strength ng buong connection, so i-multiply ko lang yung 51 sa 4 na connectors, 4 na bolts. Tapos Rn to, i-multiply ko lang siya ng phi para siya maging design strength. So, kaya times ko ng resistance factor 0.75, tapos 4 na piraso na yung bolt. Ito na yung total design shear strength ng buong connection, considering shear on bolts. So, yan yung pinakamadali, shear on bolts. Next, what about the design strength on bearing on plates? Okay, ulitin ko, pagka bearing on plates, dalawang klase, no? Pwedeng shear tear out, pwedeng hole deformation. Tapos, ang bearing ng plates, pwedeng mangyari sa tension member, sa ibabaw na plate, pwede rin siya mangyari dun sa ilalim, sa gusset plate. So, dalawa yan. So, isa-isay natin. Let's take a look first on the tension member. Okay, for the tension member. Okay. For the tension member, so dalawa, no? Pwedeng tear out, pwedeng hole deformation. So, isa-solve natin siya per bolt. Okay, so per bolt. Unahin ko muna itong say bolt number. Tawagin ito as bolt number 1, number 2, okay, number 3, number 4. Yung bolts 1 and 2, halos parehas lang sila, no? So, consider ko muna yung bolt number 1 na lang. Isang bolt, which is bolt number 1. Pagka sa tear out, ito yung pinaka mati-tear out sa bolt number 1. Diba? Itong kulay blue shaded. I don't know kung nakikita yung sinadan ko. So, ito yung LC niya. From here hanggang dito, ito yung L sub C na kailangan ko. So, 1.2 of FU. So, 1.2 of FU. Anong FU to? FU to ng tension member, 400. Tapos yung 32.5, yung 32.5 kasi is from the center eh. From here, hanggang dun sa edge ng plate. Ito yung 32.5. 32.5. So, 32.5 minus, para kung makuha yung LC, mabawas ko yung kalahati ng butas, di ba? Minus, ito yung kalahati ng butas. 1/2 of the D-hole. And D-hole is diameter bolt 20 plus 2 mm. Bakit plus 2? Kasi the diameter of the bolt is less than 24. Nakuha niyo yan? So, ito yung L sub C. Times the thickness of the tension member, which is 12. Ito yun. So, I got 123 kilonewton for tear out. Ibig sabihin, yan yung pinaka malaking Rn bago mangyari yung shear tear out. Now, what about kaya kapag shear deformation yung consider ko sa bolt number 1? Pagka hole deformation, it would be simply 2.4 FU, diameter ng bolt 20, times the thickness of the tension member 12. So, I got 230. So, pansinin mo yung dalawang values ng Rn. Sa tear out, 123. Sa hole deformation, 230. So, what does it mean? So, for the outer bolts, say bolts 1 and 2, ang mangyayari sa kanyang failure against bearing would be tear out. Diba? Shear tear out ang mangyayaring failure dun sa outer bolts number 1 and 2. So, tear out ang nag-govern. So, ito ang nag-govern, tear out. Next, let's take a look of bolts number 3 and 4. Okay, so pagka bolts 3 and 4, okay, so yung Rn niya for tear out, ito kulay red, no? Kulay red. So, ito naman yung LC niya. So, from the edge of bolt 1 to the edge of hole 3, ito yung LC na kailangan nating gamitin. And ano yung LC na yun? Ito yun. Yung 75 minus D hole. Kalahati ng hole sa kaliwa minus kalahati ng hole sa kanan. Kaya dalawang kalahati is isang buong hole. Kaya 75 minus D hole. Kasi yung 75 na ibinigay ay from here hanggang sa center ng bolt number 3. Ito yung 75. Kaya minus ko yung dalawang kalahati ng D hole. Okay, so times the thickness ulit. So I got 305 for tear out. So para ma-tear out yung 3 bolts 3 and 4, okay, so 305. What about for deformation? For hole deformation, it's 2.4 of FU, diameter 20, thickness of 12. So 230, parehas lang. So comparing 305 at saka 230, sino mas nag-govern? So for bolts 3 and 4, ang nag-govern sa kanya ay mas mababa, which is the hole deformation. Kaya ang nag-govern sa kanya is yung 230. So ituloy ko na rito. So therefore, what would be the design strength? What would be the design strength for the tension member? So that would be sa holes 1 and 2. Teka, yung phi muna is 0.75. So 0.75 yung phi. Ano yung Rn sa holes 1 and 2? Diba, yung 123 ang nag-govern. 123.84 times 2 kasi bolts na 1 and 2 times 2. Plus, sa bolts 3 and 4, ano nag-govern sa 3 and 4? Hole deformation, which is ang Rn niya is 230.4. Again, times 2 kasi bolts 3 and 4, dalawa sila. So yan, so pagka kinalculate mo yan, that would give you the answer for the design strength for tension member. Okay, sa tension member pa lang yan. Ha? So, iko-compara pa rin kasi natin yung design strength sa gusset plate, dun sa plate sa ilalim. Titingnan natin kung sino yung mas maliit. Okay, so yan na yung design strength sa tension member. Okay, next, let's take a look of the gusset plate. Okay, so yan yung gusset plate. Okay, so unahin natin muna yung, tawagin ko dito as bolt 1, 2, 3, 4. So for bolts 1 and 2, okay, so ito yung LC niya from here hanggang sa edge. So ito yung L sub C niya. L sub C. Yung center na to ay given as, ano ba yan? 37.7, 37.5. Ayan. So, ang Rn niya, considering tear out, is equal to 1.2. Oh, take note, yung FU bago na, ingat lang. Bago na yung FU kasi ibang bakal yung gusset plate. Tapos 37.5, ito yun, minus kalahati ng butas. This is kalahati ng butas. D whole over 2. So, yan na yung L sub C niya. Times the thickness of the gusset plate. Iba rin yung thickness ng gusset plate, ha? So, be careful with that. So, we got 118 to be the Rn for tear out. Now, what about for hole deformation? For the hole deformation, it's 2.4. FU 415. The diameter of the bolt is 20. And the thickness of the plate is 9, gusset plate. So, I got 179. So, what have you noticed? Sino ang mag-govern? Diba? Mas maliit si tear out. Mas maliit si tear out. Therefore, dun sa bolts 1 and 2, tear out governs din. Okay, tear out governs din. And the capacity Rn for each bolt is 118. Now, what about dun sa bolts 3 and 4? Okay, for bolts 3 and 4, ano ang tear out niya. So 1.2 of its FU. Okay, so ang LC niya is from the edge of this hole to the edge of this hole. So ito yung LC natin na gagamitin this time. Okay, pero yung center to center spacing ay given between holes to be 75. Kaya yung LC natin is 75 minus isang butas. Isang diameter ng hole. Bakit? Kalahati dito sa kaliwa, kalahati rin dito sa kanan. Kaya that makes it isang buong diameter ng hole. Then times thickness, so we got 237 for tear out. How about for hole deformation? For hole deformation, so that would be 2.4 FU, diameter of the bolt, times 9 thickness. So we got 179. Comparing these two, so mas maliit yung 179. Therefore, for bolts 3 and 4, hole deformation governs. Okay? So, pwedeng kombinasyon, no? Yung mga nasa interior, nasa exterior na connectors, pwedeng tear out, pwedeng hole deformation, pwedeng magkabaliktad, pwedeng magkaparehas. So, you have just to check for the values of its Rn kung sino yung mas maliit para mo malaman kung ano yung mag-govern. Okay? So, again, ito yung ginawa ko kanina for tension member. So, I solved for the PRN. And pag kinalculate mo yung sagot kanina, 531 yung sa tension member. Likewise, kapag sa gusset plate naman, anong magiging design strength niya? Dalawang 118, this is for bolts 1 and 2, tsaka dalawang 179 para sa 3 and 4. Yan. So the total Rn would be that value. Then just multiply it with the 0.75 resistance factor, and that would give us the design strength of 447. So dalawa, no? So ito yung design strength ng tension member against bearing. This is the design strength of the gusset plate against bearing. So ang tanong is, what is the design strength of the connection against bearing? Pag sinabing of the connection, you have to choose whichever would be smaller. So the final answer would be the smaller of 447 kilonewtons. So dapat identified nyo, hindi lang basta solve ng solve. Halimbawa, tanongin ko kayo, what would be the design strength of the tension member against bearing? So ang sagot doon would be 531. What is the design strength against bearing of the gusset plate? Ang sagot doon is 447.0795. Pagka ang tanong naman is, what is the design strength of the connection against bearing? So the answer there is 447.0795 kilograms.